The next statement that we have to prove or disprove says the following. Prove or disprove that there exists an m and an n in the integers such that m is greater than 1, n is also greater than 1, and not only that, but 1 over m plus 1 over n is an integer. So this is an example of an existential statement. It has there exists at the beginning. So if you want to prove it, then you must provide me two numbers, m and n, that are both integers, where m is greater than 1 and n is greater than 1, and the 1 over m plus 1 over n is an integer. So you can try this out. You can plug random numbers. All you have to do is find the numbers m and n that satisfy all these requirements. Turns out that this actually is a true statement, and so we would like to prove it next. So because it's a true statement, let's take a look at how to prove this. And to prove it, all I have to do is write the word proof at the very beginning to indicate that this is the beginning of the proof, and find the correct values of m and n to make the existential true. And in this case, I'm going to pick m and n to be the number 2. Now, next, what I have to do is say why these numbers are acceptable. M and n are acceptable because they're both integers and they're both greater than 1. Remember, the m and n had to be integers, and they had to be integers greater than 1. So again, even though it's kind of obvious, I'm going to have to write it down in order to bring attention to the fact that I'm satisfying the requirements of the theorem or the example. Again, this is important because m and n are required to be greater than 1 integers. And now I'm going to consider the sum of the fractions. I would like to show that 1 over m plus 1 over n is actually an integer. So to do that, I'm going to just go ahead and substitute the 2's. Because m and n are both 2, I can replace them by direct substitution, then use some algebra of fractions to add the two fractions together with a common denominator. 1 plus 1 is 2, and we divide to get 1. Now keep in mind that the 1 is an integer, and that's what we want to prove. We want to prove that the sum of 1 over m plus 1 over n is in fact an integer. Since we were able to do that, that means that 1 over m plus 1 over n is in fact an integer, when the choices for m and n are both 2 and 2. And that indicates the end of the proof. So we put a square at the end to signify the end of the proof.